To prove that air occupies space, take an uninflated balloon, fill it with air. The volume of the balloon increases. This shows that air occupies space. To prove that air has mass, take an uninflated balloon and weigh it. Blow air into it and inflate it completely. Again, take the weight. The inflated balloon weighs more than the uninflated balloon. This proves that air has mass. To prove that 1/5 of air is oxygen, fix a candle at the center of a small turrow and pour water into it. Place a measuring cylinder in an inverted position over the candle. Note the level of water in the measuring cylinder. Now light the candle and again place the measuring cylinder over the candle in an inverted position. The water level in the cylinder will rise gradually as the oxygen in the cylinder is used up for burning. Soon the candle extinguishes as all the oxygen in the cylinder is used up. At this point, the water level in the cylinder rises to a certain height and becomes steady. Now note the level of water in the cylinder. You will notice that water rises up to 1/5 of the total space that was taken up by air in the inverted cylinder. This shows that 1/5 of air is oxygen. This also shows that 4/5 part of air, which consists mainly of nitrogen, does not help in burning. To show that air contains carbon dioxide, take a test tube fitted with a 2-holed rubber cork. Fit a long bent tube through one hole and a short bent tube through the other hole. Pour some lime water into the test tube so that the long tube remains immersed in lime water while the short tube remains above it. Blow air through the long tube. You will observe that the lime water turns milky. This shows that carbon dioxide present in the air reacts with lime water to form calcium carbonate. This gives a milky appearance to the solution. Lime water plus carbon dioxide gives calcium carbonate milky. This experiment proves that air contains carbon dioxide. To show that air contains water vapor, take a dry and clean glass tumbler. Fill it with crushed ice cubes. After some time, you will notice that tiny drops of water appear on the outer surface of the glass tumbler. Where have these water droplets come from? When moist air comes in contact with the cold surface of the glass tumbler, the water vapor present in the air condenses on the cooler surface of the glass tumbler. This shows that atmospheric air contains water vapor. To show that air contains dust particle, close all the doors and windows of a room and draw the curtains so that the room becomes completely dark. Now open a part of the door or window facing the sun. You will see dust particles floating around in the beam of sunlight that enters the room through the open door or window. This experiment shows the presence of dust particles in air. To show that air or oxygen is essential for burning, fix a lighted candle in a trough containing some water. Place a glass tumbler in an inverted position over the burning candle. You will observe that the candle burns for some time and then the flame goes off. This is because the oxygen in the air trapped under the inverted glass tumbler is used up for burning. Since the water placed in the trough prevents the entry of air from below, the candle does not get any more oxygen for burning. This proves that air or oxygen is essential for burning. 8. To show that exhaled air contains more carbon dioxide than inhaled air, take 2 test tubes, each of them half filled with lime water. Using 2-holed stoppers, glass tubes and pinch corks, set up the apparatus Open the pinch cork X and close the pinch cork Y. Suck in air through the tube Z. The inhaled air passes through the lime water in test tube A. The lime water turns milky after some time. Note the time taken for the lime water to turn milky. Now close the pinch cork X and open the pinch cork Y. Exhale out air through the tube Z. Note the time taken for the lime water to turn milky in test tube B. You will observe that the lime water in test tube B turns milky more quickly than the lime water in test tube A. This proves that exhaled air contains more carbon dioxide than inhaled air. Plants produce oxygen during photosynthesis. Take a small piece of aquatic plant such as hydrilla. Place it in a beaker containing water. Cover the plant with an inverted funnel. Place a test tube full of water in an inverted position over the funnel so that there is no air in the test tube. Place the beaker in bright sunlight. After some time, you will see bubbles of gas moving into the test tube from the leaves. The water level in the test tube will go down, showing that a gas has collected above the water level. Remove the test tube carefully and introduce a glowing splinter into it. The splinter burns brightly. This shows the presence of oxygen in the test tube. The conditions of rusting. Take 3 brightly polished iron nails and place a nail in each of the 3 test tubes marked A, B and C. In test tube A, place some fused calcium chloride and plug its mouth with cotton wool. Calcium chloride absorbs moisture from the air and keeps the air in test tube A dry. Cotton wool prevents the entry of more air in the test tube. In test tube B, pour some water that has been boiled and then cooled down so that it covers the nail. Now, pour some vegetable oil over the boiled water. Boiling expels the air dissolved in water and the layer of oil does not allow any more air to dissolve in the water. The nail is now in contact with water only. In test tube C, pour some tap water and close it with a cork to prevent evaporation of water. Here, the nail is in contact with both air and water. Keep the setup undisturbed for a few days. What do you observe? The nail in test tube C gets rusted, while the nails in test tube A and B do not rust. In test tube C, the nail is in contact with both air and water, which are necessary for rusting. In test tube A, there is only air but no water, and in test tube B, there is only water but no air. So the nails in these 2 test tubes do not rust. This proves that both air and water are necessary for rusting.